In the previous lecture,
sedimentation
we discussed about the sludge
is
digestion
called
system.
activated sludge. Okay.
In this lecture, we are going to discuss about the septic
Part of
tanks.
it is
Generally,
again recycled
septic
to
tanks
the head
are
of
provided in
aeration
areas
tank
where
to be
sewers
mixed with
have not
sewage
been laid, and
being
for isolated
treated.
communities, schools, hospitals, and other public institutions, etc. Okay, let's start our lecture. Septic tanks are provided in
First, there will be
areas
a
where
primary
sewers
sedimentation
have not
tank
been led.
is connected to the aeration tank.
Generally, sewer means I told you that
Secondary
sewer is a
sedimentation tank,
pipe or a
and
conduit
then
which carries sewage. In
then
some particular
chlorination will be
areas,
place.
these sewers
Here, through
are not
primary
being installed.
sedimentation tank
In these particular areas, there is a
and the
importance of
sedimentation will be
septic
do.
tanks. And also
Here, the term very
for
important.
isolated communities,
The terminology
because
Q stands
industrials
for
and schools
rate
and
of
hospitals,
flow
these
of
are isolated
sewage.
communities. There will be a no public
suffix R is
connection
rate of
between that.
returned
There is a vacant
sludge.
tank will be there.
QE
For that,
rate of
isolated communities like the
effluent.
schools,
QW rate
hospitals,
of waste
and other public
sludge.
institutions, there is a
Here
necessity of
term XP is
septic
equal
tanks.
to mixed
Okay.
liquor
Generally,
suspended
these
solids,
septic
that is
tanks
MIS.
serves population up to
liquor suspended
300
solids
people.
in milligrams per liter in
Septic
aeration
tanks
tank.
serves
XR
population
is
up
equal
to
to
300
concentration of
people.
solids in the returned sludge.
If greater than 300 people,
XC
if greater
is
than
concentration of
300
solids
people,
in the effluent. XW is equal to concentration of
in-home
solids
tanks,
in the wasted
in-home
effluent.
tanks were used as a septic tank. Okay.
Y
Septic tank is
biochemical
nothing but
oxygen
the
demand
primary
at 5 days
sedimentation tank
of 20 degrees centigrade
with
of influent sewage.
12 to
Y
36 hours of detention
biochemical
time
oxygen demand of the
and
influent sewage.
anaerobic digestion of
P is nothing but the aeration tank volume.
Okay.
So this is the
Generally,
flow diagram
the sediment
of a
septic
conventional
tanks are
activated
rectangular
sludge process.
masonry
First, there will be a
having water
stream
type
will be there.
and air
Streams
type.
connected to grid chamber to the primary sedimentation tank,
It
primary
is the sedimentation
to
tank
aeration tank to the
with
secondary
longer detention time,
sedimentation tank to the
12 to
chlorination.
36
Here,
hours. Okay.
there will be
Septic tank is nothing but
streams.
a sedimentation tank with long detention
Streams
time having 12 to 36 hours.
grid chamber through it will be connected.
Both sedimentation and
That is what
sludge digestion
finally there will be a sludge
takes place in this tank.
in this sludge thickener will be there.
I told you septic tanks are provided in isolated communities up to 300 people population. For above 300 population, in-home tanks were used as a septic tank. But these tanks are outdated. Okay, and here rectangular masonry will be there, watertight and airtight will be there. Both sedimentation and sludge digestion.
So this is all about the flow diagram of activated sludge process.
Effluents
First, initially there will be a
should be disposed
raw
of
streams.
either for
Then
subsurface irrigation.
streams.
I told you that generally
Grid chamber
in the subsurface irrigation
tank to the aeration tank
these
to
will
the
be
secondary
used here,
sedimentation
the
tank.
effluents.
It will be connected to
So
the
effluents should be
chlorination.
disposed to the
Chlorination
subsurface
there will be
irrigation
effluents
or
to be disposed here. Here there will be
cesspools or soak
effluents
pits or treated inlet in trickling filters
to be disposed
before disposed of in water pools. Okay. The whatever the effluents coming from the septic tanks, these are disposed into the subsurface irrigation.
Aeration tank is
here in septic tanks, the sludge collected at the bottom gets digested anaerobically. Anaerobically means here there will be a absence of free dissolved oxygen. That's why the sludge at bottom will be digested. Okay? And then the digested sludge is periodically removed. Drying process. The digested sludge is periodically removed here. Okay. First, here next we'll be having the components vent of shaft activated vent shaft process. First, vent primary settling tanks. There will be a inlet zone. This is the inlet zone. This is the freeboard. First, primary settling tanks. This will be the settling zone. There will be a less detention time, 1.5 to 2 hours. Less detention this is time, the outlet 1.5 to 2 hours. Okay. Next, coming to the aeration tanks, soak pit. Generally, aeration tanks are rectangular tanks. The bottom will be having the sludge zone. Aeration tanks are rectangular tanks. Usually, will be the septic tank design will be like that only. We are having a vent shaft. Here, the inlet zone 4.5 meters. Here will be the outlet zone. This is the soak pit disconnected to the soak pit. Width will be the freeboard, and this is the settling zone 4 to okay. So these about the basic things about the septic tank. Length will be so septic tank is provided for isolated communities. 20 to receivers are not installed. Okay, it is having both sedimentation and sludge digestion. And detention time will be 4 to 8 for 3 up to 300 people. Septic tanks are designed. Okay, we are going to discuss about it is having a detention time of secondary equal to 36 hours treatment. In the previous lecture, we discussed about design of septic tank. The treatment first thing we classified into 4 stages. First one, preliminary capacity treatment. In preliminary treatment of the tank, there will be a separating of floating capacity particles. Of tank septic tank will be suspended inorganic solids. Volume of that will be done by zone plus volume of sludge zone, rich chamber, and generally the capacity of tank is equal to detritus tanks and skimming tanks. That all we discussed in the previous lecture. Volume of and then in primary treatment settling there will be a primary sedimentation tanks. Okay, plus in this lecture the secondary treatment of sewage will be discussed. In secondary treatment of sewage, the main capacity of tank is nothing but the volume removing of fine suspended particles zone that can be done by the activated sludge process. So today we will discuss in this lecture activated sludge process will be discussed, and the detention time will be 12 to 36 secondary hours. Biological wastewater treatment. So usually the major thing is that okay, activated sludge process. Then the rate of sludge activated rate of sludge process deposition is a sludge containing rate of concentration deposition will be active 30 to 40 liters aerobic microorganisms per year. Okay, the rate of 95% sludge deposition will be suspended solids 30 to and biochemical oxygen demand per person in activated okay sludge process. Next, okay, coming to the it is a period of suspended growth system cleaning. Activated sludge process is a sludge will be containing a large concentration of highly active years, generally aerobic microorganisms. It takes 1 year also. Okay. 95% removal of remaining factors and biochemical oxygen demand is achieved here. Okay. Activated sludge process is a suspended growth free board. Okay. Coming to the free board principle is equal to activated sludge is mixed with raw sewage 1.22 along with large quantity of meters air and about 4 to 8 hours in aeration tank. 0.3 meters settled sludge and length will be in secondary to sedimentation tank. This is the 3 secondary times the sedimentation tank times width. Okay. Secondary sedimentation tank is called activated sludge. Okay. So in the design criteria, part of it head of aeration tank
to be mixed with
The capacity
sewage
of septic tank, I
being
told you, is
treated.
nothing but the volume of settling zone plus volume of sludge zone, and detention time will be taken as 12 to 36 hours,
If you
and
see
rate
the
of sludge deposition
flow
will be
diagram,
30 to 40 liters per
first
person per year, and period of cleaning will be
there will
6
be
months
a
to 3 years,
primary sedimentation tank
and freeboard will
connected
be
to the aeration tank, and then
zero point 0.3 meters.
secondary sedimentation tank, and then chlorination will be taken.
Here freeboard will
Here
be
through primary sedimentation
point
tank and the sludgization
3
will be
meters,
low.
and tank depth will
Here
be
the terms very important.
1.2
Terminology
to
Q stands for
2 meters.
rate of flow of sewage.
Okay.
Q suffix R is
Freeboard
rate of returned sludge.
will be point
QE rate
3
of
meters,
sewage effluent.
and then the
QW
length will
rate
be
of
2 to 3
wasted
times of
sludge.
the width. Okay. Next, coming to the
Here term
disposal
HT is
of
equal to
effluents
mixed
from septic
liquor
tank.
suspended solids. That
The
is
effluents of septic tank will have
mixed
biochemical
liquor
oxygen
suspended
demand of
solids
100
in
to
milligrams per
200
liter
milligrams
in
per
aeration
liter,
tank.
and hence it cannot be disposed into
XR is
water
equal to
process.
concentration of solids
Understanding
in the
everyone here,
returned
the effluent
sludge.
of septic tank will have biochemical oxygen demand of
XC
100
is
to 200
concentration of
milligrams,
solids in the effluent.
and hence it cannot be disposed into water process.
XW
That
is
may
equal to
be
concentration
effluents
of
will be
solids
discharged into the
in the
subsurface
wasted
irrigation.
effluent.
Coming to the methods
Y
of
suffix I is
septic tank effluent
biochemical
disposal.
oxygen demand at 5 days of 20 degrees centigrade of the
Coming to the
effluent
methods
given.
of
Y
septic tank
suffix is
effluent disposal.
biochemical oxygen
Majorly
demand of the effluent sewage.
here
Okay.
three
T is
things.
nothing but the aeration tank.
The
volume.
effluent of septic tank
So these are
generally will have
flow diagram of
the
a
effluent
conventional
of
activated sludge
septic tank
process.
will have
First there will be a streams will be there.
100
Streams
to
connected to grid chamber to the
200
primary
milligrams per
sedimentation tank, primary sedimentation tank to the aeration tank,
and hence
aeration
it cannot
tank to the
be
secondary
disposed into water process.
sedimentation
That's what
tank
clear we can
to the
get.
chlorination.
Because
Here
the BOD will be
there will
of
be a
effluent is 100 to 200 milligrams per liter, so
streams
it cannot be disposed into water
streams
process.
through
Then how it can be disposed means
grid
there are
chamber.
three methods. One is the
Through it will be
subsurface irrigation method
that is
using
what
absorption.
finally there will be a sludge.
First one is the
Thick layer will be there.
subsurface irrigation methods using absorption
Sludge.
trenches. Here, subsurface irrigation method, the suspended organic matter
From this
present in the effluent
sludge
will be
digestion
absorbed
tank.
in the absorption trench filled with gravel. See here there will be absorption trenches will be there. These absorption trenches
So this is all
will
about
absorb
the
the
flow
effluent.
diagram of activated sludge process. So first initially there will be a
These
raw screens,
absorption trenches are
then
filled
it is
with
connected to the
gravel.
screens to the grid chamber to the primary sedimentation
So
tank,
these
primary
organic
sedimentation
matter
tank to the aeration tank to the secondary sedimentation tank. It will be connected to
this is
the
one method, that is
chlorination.
the subsurface
Chlorination
irrigation
through
method
there will be a
using
effluent
the
to
absorption
be disposed
trenches.
here. Here there will
Next,
be a
under one is
effluent
the soak pit.
effluent to be disposed.
Here the effluent is allowed to be soaked or absorbed
to be disposed
into the
here.
surrounding soil. The
And then
effluent is
aeration
allowed
tank is
to be soaked
again
or absorbed
aeration tank is
into the surrounding soil. It is filled with gravel
this
brick
aeration
bags.
tank is again seamed to the
So this is the inlet
sludge
here.
container.
Okay, this is the brickwork. Here is the
And
hose fan.
secondary sedimentation tank that we have the
So
sludge
the
digestion.
effluent is allowed to be soaked into the surrounding
Finally,
soil.
this sludge digestion
So this
tank
pit
to
is filled with the gravel and brick bags.
sludge.
Okay, this is the soak pit. Here effluents also uh, filled with absorbed by the gravel brick bags.
This is all about the flow diagram of
And third one,
conventional activated sludge process.
is a cesspool. Here, the top portion acts as
Coming to the
absorption trench,
components
bottom
of
portion acts as a
activated
trench
sludge process.
used
First,
when subsoil is porous.
primary
No
settling
well
tanks.
needed. Okay. So here, the top portion acts as an absorption trench, and the bottom portion acts as a septic tank
Primary
used
settling
when
tank.
subsoil is porous. Porous means
There will be a less detention time.
reason of
1.5
happen here,
2
and
hours.
then there is no well nearby.
Less detention
So
time.
this is the
1.5 to
cesspool.
2 hours.
Here inlet sand will be there. It acts like
Coming to the
absorption.
aeration tank.
Gravely and everything
Generally,
will absorb
aeration
tanks
tanks
coming
are
here. This is the course of
rectangular
gravel
tanks.
is provided here. This is the brick masonry.
Aeration tanks are
Solid.
rectangular
Okay.
tanks.
So these are the three methods
Depth
of
will be
disposal of effluents from septic tank
3
will
to
be there. Okay. One is the
4.5 meters.
subsurface irrigation method using absorption trenches. Second one,
Width
soak
will
pit.
be
Third one, cesspool. So generally, up to
Width will
300
be
people,
4
these
to
septic
6
tanks
meters.
will be served. More than 300 people, there is a need of in-home tanks in the place of septic tank.
Diameter.
Coming to the in-home tanks is here incoming sludge stream meter is not allowed to mix up with the sludge.
This is the most
It
common
is an anaerobic system. Okay.
of the diameter.
Septic tank is also anaerobic system. This is also anaerobic system. We need to
But
understand.
for
Here.
rectangular
Anaerobic means
tanks,
in the absence of free dissolved
depth
oxygen.
will be same,
This will
3.5
be
to
done.
4.5 meters.
The upper
And
chamber
width will
is used
be
for
less than or
sedimentation
equal
of
to 6
solids.
meters. The detention time
And the
will
lower
be
chamber is meant for digestion.
1.5 to 2 hours.
I told you that generally in
Solids
septic
loading
tank,
will
both
be
sludge
100
digestion
to 150
and sedimentation
kg per square
takes
meter
place.
per day.
Similarly, in in-home tank also,
So
both
secondary
sedimentation
time will
and
be
sludge
having both
digestion
rectangular
takes place here.
and
The
circular
upper
tanks.
chamber is
Circular
used
tanks
for
have the diameter of
sedimentation
3 to 6
and lower
meters.
chamber is for
Rectangular
digestion
tanks
and
have width
storage.
less than or equal to 6 meters.
Another thing
and
is that
depth
this
will
in-home
be
tank is
3.5
suitable
to
for
4.5 meters.
small treatment plants
And
where
retention time will be
separate
1.5
sedimentation
to
tank
2
and
hours.
sludge digestion tank cannot be constructed.
So next coming to the
This
sludge
in-home tank
thickener and
suitable
sludge
for
digestion tank.
small treatment plants where
Sludge
separate
from the
sedimentation
secondary
tank
tank
and sludge digestion tank
too much
cannot be
of
constructed.
moisture
So it is
content.
suitable for small treatment plants.
98 to 99.
And also another thing is that in in-home tanks,
the moisture
depth
content
of
is first reduced
tank
by
is more.
sending it to
Depth of
sludge thickener.
tank is more.
Then the moisture content will be reduced from
And costlier construction
98
costly.
to 93%.
Okay. So these are about the in-home tank,
which helps
in
in
in-home tank
reducing
incoming
the
sludge is not
capacity
allowed
of
to
digestion tank.
sludge. It is a anaerobic
Similar
system.
to circular
The
settling
upper
tanks,
chamber is used for
with
sedimentation
detention
of
time
solids.
of 12 to 24 hours.
And lower chamber is for digestion and storage. So it is used
Next
for
coming
small
to the
treatment plants where separate
bulking of sludge and its control.
construction. Depth of
Under
tank
strict
is
conditions,
more,
the settled sludge
and it
may
is a
contain more
costly.
moisture.
So that's all about the septic tanks.
Thus,
In this lecture,
resulting
we
in
majorly
swelling
discussed about
and
the
sludge volume.
septic
Due
tank
to
and
sludge
in-home tanks.
bulking,
I told you
it remains in
septic tanks
suspension
are provided for
and
isolated
carried
communities,
the effluent of
and where
secondary clarifiers.
there is no installation of sewers.
There will be some
Because
remedial
for isolated
measures.
communities there will be no
One is
connection
the
of sewers,
elimination
like
of
pipes and
industrial
conduits which carry
wastage,
the sewage.
chlorination
Up
of
to 300
sewage,
population septic tanks
increased aeration,
can be used.
raising
More
the
than 300
pH
population, this
of
in-home
sewage
tanks
to
are
8
used.
by adding
I
lime.
told you generally septic tank is using the
Next,
primary
coming to the
sedimentation tank
activated
with
sludge
12 to
process
36
variables.
hours of
First one
retention
is the
time.
hydraulic retention
Another thing is
time,
that in septic
HRT.
tanks, the sludge
It is
digested will be
defined
the
as the
anaerobic
ratio
system.
of volume
In-home
of the
tank is
tank
also
to
the
the
anaerobic
rate of
system is
sewage
only
flow
used here.
into the tank. That is
And
HRT
coming
is
to the
equal
design
to
of septic
E by
tank, very
Q,
important. Design of septic tank.
including sludge returned.
The
This
capacity of
hydraulic
septic
retention
tank, I told
tank
you, is nothing but the
is defined
sum of
as
the
an
volume
average
of
time
settling zone plus volume
for
of
which
that
the
sewage flowing,
and
and we
into
take
the
detention
aeration
time
tank
as 12
remains
to
in the
36 hours.
aeration tank.
Okay,
Okay.
and then the rate
Second
of
one,
sludge deposition will be
volume of
30 to 40 liters per person
biochemical
per year,
oxygen demand loading or
and
organic loading.
period of
It
cleaning
is
will be
denoted by letter
6 months
U.
to 3 years, and
This
total tank
volumetric
depth will be
biochemical oxygen
1.2 to
loading,
2 meters,
oxygen demand loading is
and the
defined
freeboard
as
will be 0.3 meters,
BOD load applied
and
per
length
unit
will be 2 to
volume
3
of
times the
aeration
width.
tank.
Okay,
U is
and I told you
equal
that
to
generally the
Q
effluent
into
which is coming from septic tank is
Y1
having the
by
high
L
biochemical
here.
oxygen demand,
Here
100 to
V
200
represents
milligrams per
the
liter.
volume of aeration
Therefore,
tank.
they cannot
Q
be
represents
disposed
the
into water courses. So there are three
rate
different
of
methods of septic tank
sewage
effluent disposal.
inflow.
One is the
Okay.
subsurface irrigation method
So
using
these
absorption
about the
trenches.
hydraulic retention tank
Second one is the soak
and
pit.
volumetric
Third one is the
biochemical oxygen
cesspool.
loading.
Generally, in a soak pit, effluent
Next
coming
third
from
one,
septic tank is
food
collected in
to
soak pit, and soak pit is disposed
microorganism
into the
ratio, that
land.
is F by M
When
ratio.
sufficient land
It
is
is also
available
called
and
as
the soil is
organic
porous,
loading.
then only this soak
It
pit
is also called as
disposal will be there.
organic loading.
Okay, and also
It is
in
defined
soak
as
pit,
the
percolation
ratio
rate of
of
soil will be
kilograms of biochemical
high
oxygen demand applied
when
per day,
less porous soil will be there. That means
representing
in soak pit,
microbial
consider two things. One is the
kilograms of
percolation and porous. When high
ml
percolation rate will
that
be
is I
there,
told
then
you
less
that
porous soil will be there. There's a vice versa. That thing we need to understand. And third one is the cesspool. In
mixed
cesspool, I told you that the top portion has
suspended
absorption
solids
tanks and bottom
aeration
portion
tank.
as a septic tank
This
used
food
when
to
subsoil is porous
microorganism
and there will be
ratio
no airway.
is equal to
Finally,
Q into
the
Y by
in-house tank.
V
I
into
told you
X1.
in-house tank
Here Q is nothing but
is
the
also
rate of
anaerobic
sewage
system.
flow,
The anaerobic system, absence of the free
and
dissolved
V is
oxygen
the
system will be
volume.
there. Here, incoming sludge
This
is
F by
not
M
allowed
ratio
to get mixed with
put to
sludge.
microorganism ratio
I
is
told you
main
the upper
factor
chamber is used for sedimentation of
controlling
solids, and the
the
lower chamber is
design.
used for digestion and
Lower
storage.
the
It is
food to
used for
microorganism
small
ratio,
treatment plants.
higher the
Okay.
biochemical oxygen demand
Another thing is
removed
that
in
the
the
depth
plant.
of the tank is more.
Usually,
And
this
comparing with the
food to
septic tank,
microorganism
these are the
ratio
costlier construction
is
also.
0.0.4.
So, so these all about the septic tank and in-home tank. Generally, the questions will be
Is
designing a
adapted
septic tank
generally.
for a colony of
Okay.
200 people.
So let me revise again.
By giving the
This
detention
food to
detention
microorganism
load and
ratio
freeboard
is
will be
also
given.
called as organic
Like that,
loading.
the questions will be asked many times.
It is defined as
Try to
the
remember.
ratio of kilograms
you,
of
everyone.